Lesson 11.1 and 11.2, simplifying operations with radical expressions. Both simplifying and operations with radical expressions. Last unit, we took square roots. They usually worked out nice. Not always. So if they didn't work out, we just put them in as decimal form. Well, us math geeks don't like that. Big reason we don't like that is we can combine them, they can divide out, we can do all sorts of things. So we have to get used to dealing with radicals without cranking them out in our calculator. So for example, square root of 32 is not clean. How do we simplify it and write it in a better way? And as I've told people before, you need these numbers: 1, 4, 9, 16, 25, 36, 49, 64, 81. And you look for these in there. You actually don't need to look for certain ones because they're covered in other ones, but this is going to be the same as radical 16 times radical 2. Root 16 is 4, so we'll get 4 root 2. I have seen people do these with the factor tree. Oh, that's 5 times 3, and then there's 2 of these. I don't recommend that. I just don't think it's a quicker way to do it. If it helps, go ahead and do it, but it's not the way I'm going to show here. So root 25 times root 3, 5 root 3. And this is just simplifying radicals. Now we've got two pieces here. We've got the x squared, which is perfect, and we'll come back to that. 24, which is 4 times 6. Now, I'm already going to get away from writing these radicals in here because we know they're all radicals and just kind of waste time. And again, my point is to save you time here. I'll leave the x squared, which I do recommend, so you don't forget about it. And the square root of x squared is x. Square root of 4 is 2, so we write 2x. The only one without a square root is 6. If it helps you, you want to leave them in, go right ahead. I'm going to pull them out. So 4 times 2 and x to the fourth. Square root of 4 is 2. Square root of x to the fourth is x squared times root 2. That's tricky stuff. And you're going to spend a lot of time practicing those problems. Don't write this down, but if you had a problem like square root of 80, you might look at that and say, oh, well, that's 4 times 20. Square root, we get 2 root 20, which is fine, but you have to also notice there's another 4 in there. So it's 2 times square root of 4 times square root of 5, which is 2 times 2 square root of 5, which is 4 root 5. Notice how much messier it gets quickly. If you can find the bigger radical, which in this case would have been root 5 times root 16, it'll save you time. But either way, you're still going to get the same answer. Just start pulling out your 4s, your 9s, your 16s, your 25s, things like that. So, multiply. Next step here. This one's big to me. Whenever you multiply a radical times a radical, the same thing. Don't do this. Just do the 6. So for example, radical pi times radical pi equals pi. Done. Don't write radical pi squared and then take the square root. You're adding an extra step. You should be smart enough to know. Radical 7 times radical 7 is 7. Simple enough. Here we've made it look a little complicated. Jam everything together under the radical. That belongs under the radical, which is 3x squared. And then you can take the x out. You get 4x root 3. Try the next two yourself. You might want to pause the recording. And now I'll do them. And we do write it this way. If we were to write it as root 2x squared, it gets confusing to see where that radical ends. So I do recommend writing as x squared root 2. So how do we do radical division? And it's really not radical division. It just means there's a radical on the bottom. And similar to how we can just jam things together when we multiply, we can also break them apart. So this is very simply root 13 over 10. Same thing here, root 7 over root x squared, root 7 over x. That's it. Going very quickly here. Make sure you take your time and understand what's going on. You can even make up example problems for yourself. Break it out. Okay? We'll give you plenty of examples to practice later in class. Now, previously we had radicals in the denominator, but they worked out nice. What if they don't work out nice? We have to do something called rationalizing. So I rewrite the problem. Whatever's on the bottom, we multiply it on the top and again on the bottom. So we're just multiplying by 1. This equals 1. We're allowed to multiply by 1 whenever we want. The reason we do this is we will get the radical out of the bottom. Why do we care? It's a good question. And the number one reason, the only reason that I've been able to find why we have to have radicals out of the bottom is this way we know what we're dealing with. If we have some radicals on the bottom, some radicals on the top, you can get very confused as to whether they're equivalent or not. You'll see some examples later where you look at it and say, oh, that's just radical this or radical that. When you, well, for example, this one. You see 3 root 3, and you have to add it to radical 3. Well, you don't know what's going on until you figure out that this is the same thing. So it'd be like adding this twice. You just get 2 root 3s, which I'll show you in a minute. So that's why we put the radicals on top. Can't have them on the bottom. We don't know if we're dealing with the same thing. This one, we just take it, rewrite it, multiply by what's on the bottom, and we cram it all together up top because they're being multiplied. And no, we can't reduce anything here. The b's inside the radical, the b's outside the radical, 6 inside radical, the 3's outside the radical. We can't mess with those. So, like I just showed before up here, how do we add and subtract radicals? Well, it's like adding and subtracting apples. 4 apples plus 6 apples equals 10 apples. Except it's not an apple, it's a root 10. 5 root 3 plus root 48. Can't add them. Don't have the same radical. Well, maybe we do, maybe we don't. We look at root 48 and say, well, that's root 16 times root 3, which is 4 root 3. 5 root 3 plus 4 root 3 is 9 root 3. So I guess we could add them. Over here we look at this and we get root 9 times root 7, 12 root 7 minus 3 root 7 is 9 root 7. That's tricky. Very doable, but tricky. You're going to have to practice those. First things first, make sure you have the same number under the radical. If you don't, like here, see if you can reduce it and make it the same number under the radical. Now, how do we multiply? Well, we multiply radical expressions the same way we multiply polynomial expressions. We just distribute. We could reduce this first, but we're going to multiply it just to get rid of the parentheses, and we'll get 4 root 5. Notice we didn't write root 5 4 because that'll be confusing whether the radicals got it or not. And then this one, they all get rammed together underneath the radical. It's 100. And then we stop and say, can we reduce? And obviously we can. 4 root 5 minus 10. This one, take your time, write them out. Root 7 times root 7 is 7. Minus 3 root 14 plus root 14 minus 3 root 4. Looking at this, we can combine these. Sometimes you can, sometimes you can't. Don't make an assumption. These problems very rarely look exactly the same. 7 minus 2 root 14. We can definitely do something with this. It's a 2. That's 6. 7 minus 6 is 1 minus 2 root 14. Gonna need a lot of practice on this, but you get the basic ideas to start. And last but not least, what do we do about a radical expression? Not just a radical, but a radical expression in the denominator. Well, that's tricky. You have to do something very different, and it comes back from your factoring practice. You multiply by what's called the conjugate. And again, we're multiplying by the conjugate over the conjugate. Because you can't multiply by any old number, you have to multiply by 1. So we get on top 2. Let's multiply it out, save ourselves some time. 12 plus 2 radical 3. And the bottom's where some neat little magic happens. 6 minus root 3, 6 plus root 3. You should remember this. 36. Middle terms vanish. Minus root 3 times 3 is 3. 12 plus 2 root 3, all over 33. Got that radical out of the bottom. Can't have it there. Try the next one on your own. See if you know what to multiply by. I'll give you a second. If you don't, I'll set that part up, and then I'll give you another second. See if you can do it yourself. Or actually, you should just pause the tape, I guess. That's what you should be multiplying by. Pause the tape if you want to try the multiplication yourself. You might think you're done, but if you look at this, you can actually cancel here and here. We didn't do it back here because we couldn't do that. We will get negative root 5 minus 1. This is a lot of material. We will practice it intensely in class, next class. So make sure you try these. Make sure you get a basic understanding. I'll go over them, and we'll go from there. Good luck.